The modern world was built on the inventions of revolutionary men. Some of these inventions shaped the way we think, act, or communicate. The machinery forged in the heat of the Industrial Revolution transformed our manufacturing process. The steam engine relieved the issues of coal mining, revolutionized agriculture and iron production, and ushered in a new age of transportation. The power of steam has been known by humans for millennia, but not until the late 17th century has the technology existed to control it. In late 17th century Britain, the mining industry was flourishing due to the demand for coal. Coal and coke were being used in Shropshire as elsewhere to make malt, glass, bricks, pottery, tobacco pipes, lime and tar, and soon afterwards for the smelting of lead ore. Unfortunately, the thriving coal industry struggled, with water flooding into the mines making it impossible to reach the desired depths. Due to this, there was a desperate need for a system to bring the water up. Before the advent of the steam engine, horses were used to lug buckets of water out of flooded mines, but this horse pulley system proved inadequately slow. To solve this problem, British inventor Thomas Savery began working on a way to harness the mechanical power of steam, and in 1698 he patented a steam-powered pump which he described as an engine to raise water by fire. The introduction of mechanical horsepower eliminated the problems associated with keeping and using live animals, which improved efficiency and profitability of the coal mines. While Savery's engine was an ingenious invention, due to its primitive vacuum chamber it was not as efficient as possible. Thomas Newcomen realized this, so he began to experiment, and in 1712 he invented an effective and practical steam engine. Newcomen's engine was the best technology for 60 years, but eventually James Watt made a breakthrough of development and created a new improved version of the Newcomen engine. The new engine used one-fourth of the steam that the Newcomen engines had required. Requiring less steam meant less fuel was required to heat water to its gas form, improving efficiency and reducing cost. With the improvements made to the steam engine, it became economically sound to manufacture them for industrial use. After realizing the potential for the Watt engine, industry leaders began to utilize its mechanical power for use in various tasks. In 1773, Watt partnered with Matthew Boulton, and together they created a new Boulton-Watt engine. In a letter to Watt, Boulton relayed his theory that the most likely line for the consumption of our engines is the application of them to mills, which is certainly an extensive field. By 1800, 84 British cotton mills used Boulton and Watt engines, along with wool mills and flour mills. Like the coal mines, the mills were able to drastically increase productivity by replacing their horses with the Boulton-Watt engine. Another important application of the steam engine was the automating of threshing grain. Before the age of steam, American farmers hand-threshed wheat or oats with a flail. Automating this process with threshing machines powered by steam engines increased daily production of threshing by 100 times. Not only did the steam-powered farm equipment ramp up production, but it also greatly reduced the operating cost by lessening the amount of feed needed for farm animals. The iron that was integral to these early industrialized machines was also forged through the utilization of steam power. The Boulton-Watt engine was capable of being applied to hammering, planing, and turning iron. By taking away the need for hand-operated machinery, the steam engine increased the efficiency of iron production enough to allow for transcontinental railroads, steamships, and automobiles. The steam engine transformed the way goods were transported in the 19th and 20th century. In 1802, Richard Trevithick patented a high-pressure engine and created the first steam-powered locomotive engine on rails. This steam-powered locomotive caught the attention of John Stevens, who in 1812 petitioned Congress to support a national railroad. Due to his efforts in 1862, Congress passed the Pacific Railway Act, which authorized the construction of a transcontinental railroad. The ability to transport goods across the country faster than ever before allowed American industry to prosper, as businesses no longer had to wait months to receive a part. Intercontinental transportation also benefited greatly from harnessing steam power. The first steamboats were small, however they still revolutionized river travel and trade and dominated the waterways. These smaller ships were soon enlarged, and by 1830 steamships were making regular crossings of the Atlantic. Global industrialization efforts flourished due to the increased accessibility that resulted from the introduction of steam-powered ships. Local transportation was also transformed with the addition of steam power. The earliest steam-powered car we know about was finished as early as 1769 by French inventor Nicolas Cugnot. Unfortunately, this automobile moved at the speed of a walk. It was not until 1826 when an engineer named Samuel Brown adapted an old Newcomen steam engine to burn gas that there was an effective, usable steam-powered automobile. Not only did the manufacturing of steam-powered automobiles launch an enormous global market, but it also allowed for swift and efficient local transportation. Steam power revolutionized the way goods were transported, from local exchanges to intercontinental trade. The steam engine may not be the most recognized invention, but without it, the world would not be nearly as advanced as it is today.